And eventually, this voltage-gated sodium channel will reach negative 55 millivolts, at which we do have the initiation of the action potential. And once it hits threshold, the action potential will occur. And that's what we call an all or nothing. Right? So in other words, the minute we hit negative 55 millivolts, there's no going back. We're going to trigger that action potential. And we're going to have a separate video that talks about how that action potential specifically works. If we go back over here, I wanted to talk about two types of neurotransmitters. We have excitatory neurotransmitters and what excitatory neurotransmitters do is, if you notice the name, it excites. In other words, that brings you closer, in this case, our axon hillock, because that's where the initiation of the action potential occurs. Closer to threshold. And we have a name for that. We call this, it depolarizes. Or I like to more say hypopolarizes, because it makes the cell less negative. In other words, if the cell is naturally at negative 70 millivolts and we open up some ligand-gated sodium channels right over here, sodium starts to rush into this region, and it makes the axon hillock less negative, right? And the axon hillock region goes from negative 70 volts to maybe negative 65 millivolts and eventually hits negative 55 millivolts. And voila, an action potential gets initiated from these voltage-gated sodium channels. And we say that if a cell is less negative, we say it's hypopolarized. Some instructors use the term depolarized. Either way, it means the cell's less negative. A good way to remember this is I like to think that polar means negative, right? And everything makes intuitive sense. Now, don't use this guideline for biology in general, but for understanding action potentials, it makes a lot more intuitive sense. So if you say the cell is hypopolarized, that means it's a less negative. Or depolarized also means less negative. Now, we can also make the cell more negative, which means the cell will less likely trigger an action potential. How do we do that? Let's say we were to open up chloride channels. Right? There's actually a neurotransmitter called GABA. And GABA is one of your most common inhibitory neurotransmitters. And why is this inhibitory? Well, let's think about it. Right? If I were to activate a chloride channel by using this neurotransmitter called GABA, which is in a red circle, that will open up this chloride channel. And since there's a lot more chloride on the outside of the cell relative to the inside of the cell, chloride will come in. And if enough chloride diffuse into the region of this axon hillock, and let's say we start off again at resting membrane potential, which is negative 70 millivolts, if enough chloride approach this region, this will become even more negative. And if this region becomes more negative, we start off over here. The cell, instead of coming up it's going to come down. So it's going to be maybe at negative 90 millivolts. And if the cell is at negative 90 millivolts, that's even further from our threshold potential of negative 55 millivolts, which means it's even harder to initiate an action potential. And we call these inhibitory neurotransmitters. Why do we use inhibitory neurotransmitters? Right? One example is anesthesia, right? We don't want the action potential to be triggered. We don't want sensation to be felt in certain regions. Now, I'm just oversimplifying this example. There are many different transmitters, neurotransmitters for different parts of your body. And in fact, most neurotransmitters work on the receptor. So some neurotransmitters can be excitatory in one part of the body, and other parts of the body, actually, it can be inhibitory. Right? So if we look over here, this brings, inhibitory neurotransmitters bring the axon hillock away from threshold. Right? In other words, this is threshold in green. We hang out at negative 70 millivolts. We actually become more negative if we were to open up some chloride channels, because we said there's a lot more chloride on the outside of the cell relative to the inside of the cell. So chloride will flow into the cell, making this axon hillock more negative. And we have a term for that. We said polar means negative in this case. So we can say the cell becomes hyperpolarized. And we're going to stop over here, and in the next few videos we're actually going into specifics on what happens when an action potential becomes initiated. So that's this part going forward.